Welcome to Unit 7, where we dive deep into the exciting world of renewable energy in agriculture. In this unit, we will explore how modern farms are adopting clean energy solutions to improve efficiency, reduce costs, and protect the environment. Renewable energy is not just a concept anymore, it's a reality on farms worldwide. Imagine solar panels on barn roofs generating electricity for irrigation systems, or wind turbines providing power for greenhouses and livestock facilities. These technologies are changing the way farmers operate, creating new opportunities for sustainability and innovation. In this subchapter, we will explore how renewable energy systems can be practically implemented on farms, focusing on technological infrastructure, financial models, and integration strategies that make renewable energy both effective and reliable. We will also discuss the benefits, challenges, and real-world examples of farms that have successfully embraced clean energy. By the end of this scene, you will understand the importance of integrating renewable energy thoughtfully and the potential impact it can have on agricultural operations, the environment, and the bottom line. Before diving into the details, let's take a moment to outline our learning objectives for this unit. By the end of this lesson, you will be able to understand the critical role of energy storage in renewable energy systems, identify different types of battery and thermal storage used in agriculture, explore smart grid and load management strategies that optimize energy use, recognize how digital monitoring tools can help track, control, and forecast energy needs. Appreciate the overall benefits of renewable energy integration for sustainable farming practices. These objectives are designed to help you connect theory with practical application. Throughout this unit, you will see how each component, storage, smart grids, and management tools, contributes to a reliable and efficient energy system on a farm. By understanding these concepts, you will gain the knowledge to plan, implement, and maintain renewable energy systems, whether on small-scale farms or larger commercial operations. This foundation will also prepare you to evaluate new technologies as they emerge in the agricultural energy landscape. Energy storage is one of the most crucial aspects of any renewable energy system. The reason is simple: solar and wind energy are intermittent. The sun does not shine at night, and wind patterns are unpredictable. Without storage, the energy generated during sunny or windy periods could go unused, leaving farms vulnerable to power shortages. Storage systems, such as batteries and thermal units, capture excess energy when production exceeds demand and release it when supply is low. This ensures a continuous and reliable power supply, which is especially important for critical operations like irrigation, refrigeration, lighting, and climate control in greenhouses. For example, imagine a greenhouse that relies solely on solar panels. During a cloudy week, temperatures could drop significantly at night, potentially harming sensitive crops. With an energy storage system in place, the greenhouse can maintain optimal conditions regardless of external energy availability. In addition, energy storage helps farms reduce reliance on external grids, lowering energy costs and increasing resilience to power outages. It also allows for peak shaving, where farms can use stored energy during high-demand periods to avoid expensive electricity rates. Understanding energy storage is the first step toward building a self-sufficient, renewable-powered farm, capable of operating efficiently in any weather condition. One of the most common and effective methods of storing electricity on farms is through the use of batteries. Batteries allow farmers to capture excess energy generated by renewable sources like solar panels or wind turbines and use it later, when energy production is low. such as at night or on cloudy days. Let's take a closer look at the two most widely used types: lithium-ion and lead-acid batteries. Lithium-ion batteries have become the preferred choice for modern agricultural systems. They are highly efficient, lightweight, and long-lasting, capable of completing thousands of charge and discharge cycles with minimal loss of capacity. These batteries are used to power a wide range of farm operations, from irrigation pumps and refrigeration units to lighting systems, sensors, and even electric tractors or utility vehicles. Their ability to deliver consistent power output, combined with low maintenance requirements, makes them ideal for farms that rely heavily on renewable energy sources. In addition, lithium-ion batteries charge faster and can store more energy in a smaller space compared to older technologies. They are also compatible with smart monitoring systems, allowing farmers to track energy performance in real time and make data-driven decisions about usage and storage. While the initial investment cost is higher, the long lifespan and superior efficiency of lithium-ion systems make them more economical in the long run. On the other hand, lead-acid batteries are more affordable and have been used in agricultural applications for decades. They are heavier and less energy-dense, meaning they require more space and maintenance. Lead-acid batteries are more prone to degradation over time and can lose capacity if not properly managed. However, for small-scale farms or as backup systems, they remain a cost-effective and reliable option. Choosing the right battery technology depends on the farm's energy demands, financial capacity, and long-term sustainability goals. For instance, a small family farm might opt for lead-acid batteries to power lighting and basic equipment, while a large commercial farm with automated systems would benefit from the durability and high performance of lithium-ion storage. In many modern setups, farms actually combine both battery types. Lithium-ion units handle critical, high-demand tasks like irrigation and cooling, while lead-acid batteries serve as backup or for non-essential operations. This hybrid approach provides a balance between cost and reliability, ensuring a steady energy supply throughout the day and across varying weather conditions. Ultimately, batteries form the heart of a renewable-powered farm. They bridge the gap between energy generation and consumption, turning unpredictable solar or wind energy into a stable, dependable resource, helping agriculture move toward a cleaner and more resilient future. Beyond batteries, farms also use thermal storage systems, technologies that store heat or cold energy for use at a later time. This approach is particularly valuable in agriculture, where maintaining the right temperature can make the difference between healthy crops and spoiled produce. Thermal storage is commonly used in greenhouses, cold storage facilities, and climate-controlled livestock buildings. During the day, renewable energy sources such as solar collectors or heat pumps capture and store energy in the form of heat. This heat is transferred to water, air, or specialized thermal fluids, which are then stored in insulated tanks or reservoirs. When temperatures drop at night, the stored heat is released slowly to maintain optimal growing or housing conditions, all without relying on additional electricity or fossil fuels. The same concept applies to cold storage. Surplus renewable energy, like solar power during peak daylight hours, can be used to generate ice or chilled water. This stored, cold energy is then used to cool produce, dairy, or meat during the hottest parts of the day. For instance, a dairy farm can create ice using excess solar energy and later use it to keep milk tanks at a steady, safe temperature. This not only reduces energy consumption but also helps prevent spoilage and maintain product quality. One of the greatest advantages of thermal storage is load shifting, the ability to use energy at off-peak hours when demand and costs are lower. By capturing heat or cold when renewable energy is abundant, farms can use it later when the sun isn't shining or the wind isn't blowing. This flexibility reduces strain on both the farm's electrical system and the broader grid, while lowering energy bills and improving overall efficiency. The benefits of thermal storage go far beyond simple cost savings. These systems contribute to energy independence, climate resilience, and sustainability. They allow farmers to control their environments naturally, creating stable conditions for crops and livestock year-round. In short, thermal storage bridges the gap between energy generation and energy use, helping farms make the most of every ray of sunshine or gust of wind. Let's look at a practical example of thermal storage in action. In a greenhouse equipped with solar collectors, water or fluid is heated during sunny hours and stored in large insulated tanks. When evening comes, the stored thermal energy is circulated through the greenhouse, maintaining temperatures that support plant growth and prevent crop stress. For cold storage, ice or chilled water created during periods of high energy availability can cool storage rooms during peak heat hours. This approach reduces electricity consumption and ensures products remain at safe temperatures, even if renewable generation fluctuates. Thermal storage systems are often integrated with smart grid controls, allowing automated management of heat or cold release based on real-time energy availability and environmental conditions. For example, if a cloudy day is forecasted, the system can preheat or pre-cool areas to maintain stability. These systems demonstrate how farms can use renewable energy more effectively, ensuring that heat and cold are available exactly when needed. It's a simple concept with a profound impact on energy efficiency, sustainability, and operational reliability. Smart grids are modern electrical networks that use digital technology to monitor, control, and optimize how electricity flows between power sources and energy users. They represent the next generation of power systems, intelligent, flexible, and responsive, enabling renewable energy to be used efficiently and reliably in every part of a farm's operation. In agriculture, smart grids bring together solar panels, wind turbines, batteries, and other distributed energy sources into one coordinated and intelligent network. Sensors placed throughout the system constantly measure how much electricity is being produced, how much is stored, and how much is currently being consumed. Automated controls then direct energy exactly where it's needed most, to irrigation pumps during the day, greenhouse lighting at dusk, or cooling systems during peak heat hours. This kind of coordination helps reduce waste, avoid overloads, and ensure that renewable energy is used to its full potential. For example, irrigation systems can automatically operate during periods of high solar output, while less urgent equipment, such as water heaters or grain dryers, can be delayed until surplus power becomes available. In this way, smart grids help farms make the most of every watt of renewable energy they generate. Another key benefit of smart grids is integration with the national grid. When a farm produces more electricity than it needs, the excess power can be sold back to the grid, generating additional income. At other times, such as during long periods of cloudy weather, the same grid connection allows the farm to draw energy when renewable generation is low. This two-way flow of energy makes farming operations more stable, flexible, and financially sustainable. Advanced smart grids go even further, incorporating predictive and adaptive features. By using weather forecasts and historical data, they can anticipate fluctuations in solar or wind energy. If cloudy or calm conditions are expected, the system may pre-charge batteries, limit non-essential operations, or adjust temperature controls to maintain balance. These predictive capabilities make the entire network proactive instead of reactive, a critical advantage for ensuring reliability in variable environments. Ultimately, a smart grid acts as the digital nervous system of a modern renewable energy farm. It connects all the pieces, generation, storage, and consumption, into one intelligent, self-regulating ecosystem. By adopting smart grid technology, farms gain greater energy independence, operational efficiency, and sustainability, ensuring that renewable systems continue to deliver power when and where it's needed most. Digital monitoring tools give farms the ability to track and manage energy in real time, transforming the way renewable systems are used. Through a combination of sensors, smart meters, and software dashboards, farmers can see exactly how much energy is being produced, stored, and consumed at any given moment. These tools provide valuable insights that help optimize performance and prevent energy waste. For example, monitoring platforms can display live data on solar panel output, battery charge levels, and irrigation pump operation. If production suddenly drops or consumption spikes, the system immediately alerts the user, enabling quick action before problems escalate. Automated systems then take this data one step further. They can start or stop pumps, lights, or ventilation fans automatically, based on available energy or environmental needs. This means energy is only used when it's actually required, reducing costs and extending battery life. Forecast-based automation brings even greater intelligence. If cloudy weather is predicted, the system can pre-charge batteries, postpone certain energy-intensive tasks, or adjust cooling systems in advance. Likewise, when a sunny or windy day is expected, operations can be scheduled to make full use of the incoming renewable energy. This proactive management ensures energy availability, reliability, and maximum efficiency. Digital monitoring also supports predictive maintenance. By continuously tracking system performance, software can detect early signs of wear, overheating, or component failure. Farmers can plan maintenance before breakdowns occur, saving both time and money. Historical data helps identify patterns and make smarter investment decisions, such as when to upgrade storage capacity or add new panels. Finally, these technologies make farms more autonomous and data-driven. By combining automation, monitoring, and analytics, renewable energy systems become easier to control, more efficient, and better adapted to real-world conditions. The result is a farm that operates smoothly, sustainably, and increasingly independent from external power grids, a true model of modern smart agriculture. Effective energy management provides numerous advantages for agricultural operations. First, it reduces energy waste, ensuring that every kilowatt generated is used efficiently. Second, it extends the lifespan of batteries and other equipment, preventing damage from overuse or deep discharges. Third, it supports grid stability, particularly when farms participate in net metering programs. Precision agriculture also benefits. Automated irrigation, climate-controlled greenhouses, and livestock systems can operate reliably and sustainably. Additionally, smart energy management improves resilience to weather fluctuations, energy price spikes, and unexpected power outages. It empowers farmers to make informed decisions about resource use, planning, and investments. In short, integrating storage, monitoring, and management systems allows farms to be more productive, sustainable, and energy independent. In conclusion, energy storage, smart management, and digital monitoring are essential pillars for renewable energy in agriculture. They ensure a reliable power supply, reduce costs, enhance efficiency, and support sustainable farming practices. By combining these technologies, farms can operate independently, efficiently, and resiliently, even in the face of fluctuating weather and energy demands. Embracing renewable energy is not only an operational improvement, it is a step toward a greener, cleaner, and more sustainable agricultural future. Farmers around the world are already demonstrating that renewable systems work in practice, providing a blueprint for others to follow. Thank you for joining us on this journey through renewable energy in agriculture. We hope this unit has inspired you to think critically about energy use, explore new technologies, and apply sustainable practices on farms or projects you are involved with.